Okay, geometry, here are some more helper notes for you. So here are the notes on patterns, but this time in multiple representations, including graphing. So in class, you were able to pick whichever pattern you wanted to pick to put on here. So if you already did one, then that's great. If you didn't do one yet, though, here we go. So I kind of like the pattern with the triangles. So step one looked like this. And step two looked like this. And then they added two more triangles. And they added two more triangles to that. So that's the same. Now I got to add two more triangles. So notice I'm trying to repeat the same pattern again and again. So then step 0, since would be two less triangles. So here I'm adding two more triangles each time. I'm adding two more triangles each time. So step 0 would have to be one triangle, because if I have that one middle triangle and I add 2, I'll end up with 3. Okay, so for my table, n is my step number. So I can make a note of that, step number. F of n, that's the number of triangles. In this case, it's triangles, number of triangles, because that's what we're using in this particular pattern. So step 0 is 1, step 1 is 3, step 2 is 1, 2, 3, 4, 5, step 3 is 1, 2, 3, 4, 5, 6, 7, and I can see my step number, my rate of change, rather, I can see my rate of change right here. I'm adding 2. 1 plus 2 is 3. 3 plus 2 is 5. 5 plus 2 is 7. So that is my rate of change. So my rate of change is positive 2. Okay, my starting point is is step 0. This is what we call our starting point. And step 0, here's my step numbers. Step 0 is right here. So my starting point, if I graph my table, is 0, 1. So here's my starting point. I can see it in lots of different ways on this paper. This is my starting point. That's step 0. Here's my starting point, and here's my starting point. So I can see it in the table. Here's my starting point. I can see it in the picture as step 0. I can see it on my graph on the y-axis. So what's my starting point? 1. It's positive 1. Now the function rule, we were practicing this in class. Our function rule is we write f of n, let me get a different color. F of n is equal to, oh, that's not working, is equal to the rate of change times n plus the starting point. So that's a really simple way to write a function rule, is by finding the starting point. So here's my starting point right here is 1, finding the rate of change, and then all you have to do is put the rate of change times the step number plus the starting point. Okay, so I'm going to annotate this as well. Here is my my rate of change. And this is my starting point. Okay, now let me just finish up my graph and we'll be done. So on my graph, I already graphed my starting point. So now I have on step 1, I have 3, 1, 2, 3. Step 2, I have 5. Step 3, I have 7. And I could keep going. Notice each step, I go up 2. Each step, I add 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 2. I can go all the way across. Now, I am not going to connect my dots because it's for a pattern and it's not continuous. This graph is discrete because it's for a pattern. There's no such thing as step 1/2 or step 1.5. Doesn't exist. All right, that's it. Those would be my notes that I would then put into my notebook. That's what I would put in. Hope that helps. Bye-bye.